Hi, fourth grade. Here we are, lesson 3 of unit 2, and I'm on page 49 of my SAB. So today we're going to be looking for patterns in multiplication. When we're multiplying greater numbers in our head, it's easier when you learn patterns of multiplication with tens. So let's check this out and see what they mean by a pattern. We're going to be looking at table 1. It says start with column A and look for patterns used to get the expressions in each column. Copy and complete the table. So here for A in the first row, 2 times 3. Well, we know that equals 6, but what does all this mean? Oh, okay, they broke apart the 2 to show 2 times 1, and they broke apart the 3 to show 3 times 1. Does that make sense? So 2 times 1 equals 2, 3 times 1 equals 3. Then, what did they do here? They switched where they were imagining the parentheses. So instead of 2 times 1, they're pulling that 2 and the 3 together. 2 times 3 equals 6, and then 1 times 1 equals 1. So we've got them separated now for the C column where we have 6 times 1. And then in the D column, you're just putting the answer. So you're just putting in the answer to the multiplication problem. So then for A, down here for the second one, 2 times 30. The only thing that's changing here is that we are adding a place value to 30. So instead of 3, now it's tens. So let's see. First of all, let's break apart the 2 and 1. And then let's break apart the 30, 3 and 10. So we have 2 times 1 and 3 times 10. And we're looking at how that looks a little bit different. We see a pattern going though, right? 2, 1, 3, 1, 2, 1, 3, 10. And again, if we were gonna just circle the 2 and the 3 to show 6, then we would have the 1 and the 10 left. 1 times 10 equals 10. So maybe you're seeing some patterns there. I'm going to erase all these marks because they may also make it harder for you to see the patterns. Okay, what is 6 times 10? 6 times 10 is 60. So notice that they've gone from 2 times 30 to show 60 to 6 times 10 to show 60. They are changing it from the 2 times 3 to just combining the 2 and the 3 to 6 and then showing that place value number. Okay. 20 times 30, same thing. We're pulling apart the 2 and the 10, here we go, to make 20, and then 30 is made by 3 and 10. Again, grabbing that 2 and 3, so grabbing those first 2 digits, 6 times, now instead of a 10 here, we have 2 tens, 10 times 10. And remember, it's multiplication because we have all those multiplication signs in there. 10 times 10 equals 100. 6 times 100 equals 600. So do you see the pattern there? How it goes 6 times 1, 6 times 10, 6 times 100, 6, 6 with 1 0 after it, 6 with 2 zeros after it. How are the expressions in column B different from the expressions in column A? Well, in B, they're broken apart, right? You don't have to write that today, but you would see that, you can observe it, that they're broken apart. In A, they're put back together. In column C, we see that each expression can be written as a number times a place value. Which of these factors gives more information about the size of the product? I do want you to think about that. So let's look up here at column C. By factor, they mean which one of these numbers that you're multiplying gives you more information about how big your answer is going to be. Would it be the 6 or would it be the 1, the 10, or the 100? It would be the second one, right? The 1, 10, or 100, because that's going to show, oh yeah, my number is just going to be in the ones place. My answer is just going to be in the tens place. My answer is going to be in the hundreds place. So you can see that this second factor is super important. They're trying to demonstrate to us that what we're multiplying something by really makes a difference as to how big it will be, how large the number will be. And in that, we can start making predictions about what answers would be reasonable. Okay, and then if we're looking down here at number 5, why is the 6 the first digit in the products column of column D? Why is there 6 first in all of these? And that is because simply you have 6 first over here, right? that you're just multiplying 6 by some tens, whether it's 1 10 or 2 tens. And then last but not least down here, why are there different numbers of zeros in the products in column D? Well, that would be because you have different amounts of tens or hundreds that you're multiplying by, which result in different zeros. I think you probably already know this, but let me quickly do something. Do you guys already know that anytime you're multiplying something by a number that has just one digit and then zeros after it, all you have to do is multiply the number by the first number. So 5 times 2 is 10, and then count your zeros. 1, 2, 1, 2, and there's your answer. So there's really good mental math they're showing us here as well. When we're multiplying by a number that has zeros and only one digit in the beginning, it's really super easy. Let's try this one. 7 times 30. That's a weird 3. So again, 7 times 3 equals 21. How many zeros? 1 0. It can also be true if you have more than 1 0 in different numbers, or 1 0 in different numbers, or more than one. 7 times 3 equals 21. Count your zeros. 1 2, right? There's 2 zeros. 1 2. The answer is 2,100. Really good trick to know if you're multiplying by numbers with a 0 at the end, with zeros. Okay, so the next thing we're looking at is table 2, and this one is very similar to the last one. You're just looking at how the numbers are broken up, and they just go a little bit higher this time. So take this one on your own. Try to complete it if you can, but remember that today in your online assignment, you're going to be doing these as well. So just thinking very carefully. We're going to do table 3 together. That's the last one. So let's look at table 3 together. We have 5 times 80 here. So we're showing 5 times 1, that's the 5. I could even put parentheses around that if I wanted to. And then 8 times 10, that equals the 80. And then here, what are they doing here? Where did they get the 40? Oh yeah, they pull out the 5 and the 8, that becomes the 4. And then they pull out the 10 and the 1, that becomes the 10. But why is this 40 now? Why are they showing 40 here times? Remember, that's because 5 times 8 is a 2-digit number. 5 times 8 is 40. So that's why you're seeing a 2-digit number here instead of a 1-digit like we saw in table 1. What is 40 times 10? Ooh, let's use that trick. 4 times 1 equals 4. How many zeros? 2 zeros. All right, last but not least, we've got 5 times 10 times 8 times 10. Where did I get those 10s? Because 5 times 10 equals 50, 8 times 10 equals 80. And then I have to stick with this same pattern over here. So I see 40, 40, 40. If I see things twice, I know that the third one's probably gonna have to be the exact same. What would 40 times though? Would it be 40 times 1, 40 times 10, 40 times 100, because there's 2 zeros there. 0, 0, so 2 zeros. And then when I'm multiplying, how many zeros total in my answer? 1, 2, 3. 1, 2, 3. And then I put my comma in. There are some questions down below, but I've already covered them during this explanation, so you should be good to go. Good luck today on your math expressions.